Well, what you see here in the back of me is a test setup which is located in one of the underground parking spaces of Ghent University. The space was available during the Corona crisis to build a large duct system in which we do experiments to improve the airtightness of the system and to reduce the flow resistance of the system. Both the airtightness and the reduction of the flow resistance are important to reduce the energy consumption of the fan, the electrical energy consumption, which is an important element in the overall energy use of buildings.
For the pressure loss testing, we have installed a large ventilator at the main duct of the duct system. So the ventilator extracts a lot of air at a very high speed, and the ventilation ductwork consists of one main channel and 6 side channels to represent a real-life ductwork in a building. So we opened all 6 of the side channels one by one, and we did pressure loss tests at different points in the network. And if we measure the pressure at different points in the network, we can calculate the pressure loss over certain elements in the network, which tells us something about flow resistance of the components of the network and the material itself.
Smoke extraction ducts, that's that you can see here. That's what we already have as a ProMat company already long in our portfolio. But up to now, we only looked at small elements that we put on a furnace to check the fire resistance. And this is interesting because that's of course the first thing that you want to check. But there are also engineers who need to design the system to think about the layout, the sizing of the elements. But that's one part, and the second part is that we want to upgrade the system to also normal ventilation purposes. It will be a cost-effective solution if they have a smoke extraction duct system combined with normal ventilation. Normal ventilation, then they don't have 2 separate systems, so it will be cost-effective.
This new ducting project from ProMat really contributes to a new culture of sustainable construction. How? By the fact that we develop one system that can be served for both ventilation and for smoke extraction with less use of energy.
What makes me really proud is again that we have this collaboration of all these experts and that we can go a step further than we otherwise would have gone. So now we can do these tests, and these tests are not that easy. So again, the university is actually working together with IFI from Aachen to complete these tests. And this is a unique set of data for us, but also for the world. It's something new, it's unique. So in the end, everything that we are now producing is really unique and new, and we are excited, of course, about bringing this to ProMat and to the rest of the world.
Well, at Ghent University we do academic research, sometimes fundamental research into the flow resistance, the airflow in buildings, and by collaborating with industry, our new models and knowledge can be applied into practice to create tangible systems and create solutions for society.
ProMat wants to work closely with governments, institutions, the academic world to develop new solutions that can help us to develop more circular construction methods. This is why we are so happy with this project, where we actually develop a new solution for architects and engineers that will help them to build in a more sustainable way.